Hi guys, this week we are talking about air pressure and air masses and fronts. The first thing we're going to talk about this week is air pressure. We need to be thinking about air as particles. Many different particles, oxygen, nitrogen, carbon dioxide, that is all around us in the atmosphere. So air doesn't feel heavy to you, but actually it is pushing down on you all the time with gravity. So of course, closer to Earth, the air pressure is higher because the molecules are pushed more closely together. And as you get higher up in the atmosphere, the air pressure is less and less, and that's thin air. So high altitude places have very thin air. In levels of the atmosphere like the thermosphere and the exosphere, there's almost no air pressure because the molecules have spread out so much and gravity has weakened its pull. So as I already said, elevation greatly affects air pressure. At higher elevations, the air pressure is lower. So here at Mount Everest, there's a lower air pressure than there is here at sea level. Sea level is where the highest air pressure would be. Makes sense because that's the lowest level and the air is getting pushed down into this space, rather pulled down by gravity. Air pressure is also greatly affected by temperature. So when there is high temperature warm air, the air pressure decreases, and that's because warm air is less dense than cold air. So because of this, the air more easily rises up, which means that less air is getting packed in close to Earth. So the pressure gets lower. The opposite is true with cold air. Cold air sinks, and so as it's sinking, it's getting more and more packed down here close to Earth, so pressure is increasing. Here the molecules would be more spread out, lower pressure. So now that we've talked about how air pressure works and how air itself works, we need to talk about air masses. Air masses are groups of air that have the same qualities. So this one here is a maritime polar air mass, which means that it is from the ocean, that's maritime, and cold, that's polar. Here would be a maritime tropical, so this is moist from the ocean, it's going to have a lot of water in it, and warm tropical. So there are all these different types of air masses that are always moving around the Earth, and they're affecting the weather and climate of the areas that they cover. Also important to remember that these sorts of air masses are all moving within the troposphere because that is the area closest to Earth where the weather happens. So here's just another image that shows you that the air masses are always moving. This green line is super important. It's the jet stream. It is a very strong wind current that controls where air masses move. And so the jet stream also changes. So right now, the jet stream is keeping this cold air mass to the north and this warm air mass to the south. However, if the jet stream were to dip lower, let's say it dips lower like this, now the cold air mass would be able to intrude into the area that is where North Carolina is. So because that boundary's gone, all of this area would now have the cold air mass. So when we experience colder weather, it's because a polar air mass is able to dip down because the jet stream has dipped down. Okay, now I'm going to talk about two types of air fronts. So when an air mass moves, the leading edge is called a front. So this edge right here is the front of the air mass. In a cold front, which is what I'm going to talk about first, the leading edge is of a cooler air mass. So that's this blue mass right here. This causes warm air to lift up, as you can see here. The warm air is lifting, and that's because the cold air is more dense than the warm air. And so it sinks down and displaces the warm air. This leads to lower air pressure at first, but then eventually higher pressure because the cold air moves in. Cold is high pressure, and they move faster than a warm front would move. On a weather map, you would see a cold front looking like this. It's pointed triangles and it's blue. The triangles point in the direction that the front is moving, so this front is moving this way. So similarly, warm fronts are the leading edge of a warm mass of air. They lead to higher temperatures and actually heavy rain. That's because the pressure decreases when the warm air moves in because of the low density of warm air, like we talked about before. So as the pressure decreases, we'll talk about this in just a minute, but the storms come in. On a weather map, the warm fronts look like this. They have a circular shape and a red color, and they also move in the way that the circles are facing. So this front is moving in this direction, pushing the cold air out. So just so you can see what this would look like on a weather map, you can see the different fronts that are happening here. This is a cold front. It's moving out towards sea because that's where the arrows are facing. This cold front is moving right behind that one towards North Carolina. This warm front is moving in this direction. And then these areas are high and low pressure. So the high area pressures are these blue H's and the low area pressures are these red L's. The white lines that you see around the map are representing wind patterns. Also check out that around the low pressure symbols there seems to be more rain and precipitation, maybe snow. And in the high pressure areas there's almost no precipitation. Maybe some cloud cover, but not a lot of precipitation happening in high pressure areas. So now that you've seen them on a map and you know that cold fronts lead to high pressure and warm fronts lead to low pressure, this is a little cheat sheet for you to check out. So low pressure leads to storms, tornadoes, hurricanes, generally bad weather. You can remember this because when you're feeling low, you're feeling bad. This makes sense because on really hot days, we often have storms. That's because the warm air causes the pressure to decrease. And then high pressure days are these beautiful days with dry conditions, clear skies, sunny, beautiful. And you can remember this because H is for happy. You're happy when you have clear weather. All right, that's it for this time. Hopefully you learned something about air pressure, air masses, and fronts. Make sure you do your discussion post, and I'll see you again next week. Bye.